This is a very general introduction to the FAIR data principles. I basically plan to take you on a journey to explore what they are and what each guiding principle of the FAIR means, and hopefully I can also get you inspired on some ways of how to implement them and make your data fair. So let's start with a bit of motivation. So in this slide, you see two key stakeholders in the scientific research process. So one are researchers conducting experiments in the lab, and to the right, you see the other scientists or the scientific community, which are benefiting and looking forward for your research outcomes. Communication between these two stakeholders of the research outcomes between them is important to expand and contribute to the human knowledge. Traditionally, the key outcomes of the research process have been communicated through journal publications, patents, or dissertations, or even in the closed rooms in conference presentations. The sharing of the data has been limited and often conducted through informal means and private requests. If we take a step back and think again about the research process and ask ourselves, what are the actual research outcomes? The question is, as Samak highlighted, it is the research data. So when you do an experiment, you get data, not a paper. And then you create the figures, you write the publication, and you share the new information based on this data. If we shift our view on the key outcomes of scientific research from being publications to being research data, then we realize now how important is it to share our research data. Furthermore, to advance new discoveries and the exploration of new materials through machine learning and artificial intelligence, it's required to create and share these research data in a manner that they are accessible and readable by both humans and machines. However, sharing research data comes with several challenges. Large and diverse amounts of data are being produced every day, and they are shared in isolated silos with varying levels of inconsistent documentation, and this puts a very large challenge on how data can be shared. The FAIR data principles come to the rescue, and they have been developed to address these challenges and to transform how data is managed and how it's shared and utilized to promote greater transparency and collaboration. FAIR is an acronym for findable, accessible, interoperable, and reusable. But I'm sure you all know this by now. These four words represent the key objectives that, when accomplished, the value of the data and the data sharing process would become more efficient and more effective. They were developed by a group of scientists who recognized the need of a more comprehensive data sharing practice. They were first published in this article by Wilkinson in 2016, and it quickly gained recognition, being applied by various research communities, institutions, and being incorporated into numerous policies and guidelines. If we try to describe each of these objectives in simple terms, so findable is basically the ability to locate and discover the data, and this applies to both humans and machines. Accessibility means that humans and machines can gain access to the data once they are located. Once you found them, then accessibility means that you can access them. After you can access them comes the interoperability principle, which indicates that the various processes such as combination, exchange, or analysis on the data can be performed even if the data comes from different sources. And reusability means that the data can be reused in different contexts than they were originally prepared for. The FAIR data principles guide us to achieving those objectives, but let's look into let's take a deeper look on what they really are. So they are guidelines, so they are not implementation policies or standards. They are simply guidelines that aim to improve these four objectives of all digital assets, including research data. They do not dictate a specific technological implementation. Individual communities, me and you, can implement them as long as you can achieve that objective. And they aim to enhance the reusability of the scientific data and especially emphasize in making these processes on the data are machine readable and AI ready. They comprise 4 foundational principles and 15 guiding principles. The 4 foundational principles define the core objectives, as I just mentioned, and they form the acronym FAIR. And then they are broken into 15 guiding principles. They provide a more explicit description to the foundational ones and also provide guidance and measurable actions to do them. The guiding principles are labeled by the letter of the acronym and a number. And keep in mind that these numbers do not reflect precedence or importance because the FAIR data principles are related, but they are independent and separable. Some of the principles, you can find that there are subsets of one of the main guiding principles, and this indicates that they provide more insights or more descriptions to the parent principle. So in the following slides, we will go through the 15 guiding principles, and we will start with the findability. So if you look at the screen now on the slides, you see a picture of a large number of diverse construction pieces, the toys. They are laid out randomly on a surface. Imagine that each piece in this picture is a data set that has been collected on the lab. How efficiently can you pick up the piece that you need to prepare a specific design or a useful construction? I think it's not very efficient. All of us will agree on that. This represents the issue with non-findable data. So without being able to quickly locate your data or anyone else's data, you cannot create new information or knowledge out of it. It would be easier sometimes that you decide, okay, I'm not gonna spend time looking for that data, but I'll just repeat the experiment to acquire like a new data set on the same context. That's a waste of resources. Furthermore, others cannot find your data, and this would lead to missed collaboration or interdisciplinary research. The Findability Foundational Principle and its 4 guiding principles aim to resolve these issues. So in general terms, they emphasize on that data need to be assigned with a persistent identifier, which can be used to call them. Data should be described in as much details as possible using rich metadata. And the metadata are always connected to their data using the persistent identifier. And this accounts for cases where both data and metadata are stored separately. And finally, they emphasize as well on that data should be possible to be searched for using certain platform. Just before we go further, I want to emphasize like the difference here. When you see metadata with meta between parentheses, it means that the principle here applies to either data or to the metadata, or both. And when you see just metadata written, it means that, like in the case of F3, it only applies to metadata. So let's go through these principles now. And we start with F1, which describes the most fundamental guiding principle in the FAIR principles. So if you want to locate your data, you need to call it. And to call things, use names or labels. These names or labels identify the data and thus are called identifiers. And to ensure that every time you or other people or a computer call a specific data set, the same intended data is located, this identifier must be unique and persistent. And this is what lists in this principle here, that the data should be assigned a globally unique and a persistent identifier. The globally means that it only refers to one item in the whole universe, and the persistent means that it's long-lasting reference, so it will stay and will point to the same data even if the data are deleted or removed. For example, if we look at, again, to the construction pieces, which I like to look at as data, you can see that each item has a unique number that's assigned to it, and this can be considered as a persistent identifiers, which you can use in a search engine, for example, on this website shown here, to find these pieces. Now, what if you don't know the identifier to call the data? Then F2 comes here to help, and it enables the possibility for you to discover, for you and others, to discover and locate data using search terms or filtering by setting a requirement that data should be described using rich metadata. For example, using the same example as the construction bricks, you can see that metadata could be color, could be a category, or could be a part, and you have to describe your data as richly as possible with metadata to satisfy F2. F3 indicates that if you have the data which has been assigned a persistent identifier and they have been richly described with the metadata, F3 requires that the identifier should be a part of the rich metadata. This means that any description of the data must contain the identifier. This is important to account for the situation where you acquired your data, but for example, you recorded your metadata using a separate Excel sheet, or you did it on your electronic lab notebook. So you have to link it to your data using the persistent identifier. For example, look at this data here, which again, I use the example of the construction pieces. You write your metadata into different categories, and then finally you write the persistent identifier for the data which links to this item. To enable locating and finding your data, then comes principle F4. It states that both the data and the metadata should be searchable using a platform or an infrastructure which have the data indexed in them. Then the indexed data can be discovered by using the attributes that have been richly described using F2, and then located using the identifier, F1, or the connection to the metadata in F3. For example, in this screenshot, I also show this platform for searching the construction pieces, and here you can see that all the items are cataloged and indexed and can be found easily using search terms in the search engine. So let's move to the next principle. Now, locating the data is only the first step towards fair data sharing. The next step is to have access and to put your hands on them. And several issues arise when data are not accessible, such as the lack of a clear access rule for both data and metadata, or restricted access to the experimental conditions of a specific data. And this wastes time in your attempt to figure out, like, can I use this? Like, can I access this, or should I ask someone to access this? And also hinders the ability to verify or reuse the data due to access restrictions. The accessibility foundational principle and its four guiding principle aims to resolve these issues. So in general terms, they emphasize the need for an open and free communication protocol to retrieve the data and their access rules. And they specify that at least the metadata are accessible, even if the data is restricted for some reason. So for principle A1, it focuses on the retrievability of the data once they are found using the identifier. So to retrieve the data, principle A1 states that this is achievable by using a standardized communication protocol. A communication protocol is simply a standard way to communicate between two parties to request the data. For example, this could be me and you using a set of controlled verbal communication. If we are collaborating on a project, and now let's agree that we provide each other with a well-constructed sentence when you ask for each other's data. For example, you start with your request, share, copy, or upload, then please add the data identifier, and then please share the medium that you would like me to perform this task with. And this could be like the verb or the sentence that we'd use, like Ahmed, share the data with the persistent identifier X1, Y2, Z3 via email, please. So this is a communication protocol that defines the rules for this statement. In more technical terms, it is a protocol that allows to share data in a predictable way and to access it, use it an agent or a human. A common example is the hypertext transfer protocol, which is commonly used to access all the web pages and everything on the internet. Now, let's look at examples using the construction pieces. So if you access this search platform for the data in this example, and you click on this, then you can access the item and its information using the HTTP address or the HTTP protocol shown on the top. A2 adds another guideline to enhance the accessibility of the data, which says that if the data is not available for some reason, it's under embargo or it's restricted because the user does not want to share it, at least the metadata should be accessible to provide an understanding of the data nature and its provenance. Principles A.1, A1.1, and A1.2 further detail the requirements of the communication protocol. They simply specify that the protocol should be open and free and anyone can use it and learn it. And the second requirement is that access restrictions could exist using this protocol based on ethical, legal, or contractual constraints. And this basically relates to the fact that fair data does not mean open data. Then we need to authenticate the access request by confirming the identity of the requester and authorize them to access data to ensure that their credential match the rules set by the data provider. So we have talked about locating the data, then accessing the data and having our hands on them. The next step is to be able to work with the data, such as verifying it, running additional analysis, or combining them with existing data that you might have. This can be challenging, especially that data are produced by different resources and documented using different standards and level of detail. Look at this example of historical construction pieces that were produced at different times by different vendors using different standards. You can see that combining these pieces together can be challenging. This represents the issue with lack of interoperability of data, which have several challenges. Simply, in simple terms, like if you have a data file, you might need specialized tools or software to open or work with certain data. Combining data from different sources will be hindered because the data are structured differently. Also, confusion in understanding the quantities because they are labeled differently by different users or different instruments. The interoperability foundational principle and its three guiding principles aim to resolve these issues. They mainly provide guidelines on the language and controlled vocabulary to be used to describe the data and connecting different data sets together using qualified references. So let's go into these in more details. So I1 is about how we describe our research data. Data description should be done consistently to ensure that different parties understand the various parameters and the metadata associated with the data. For example, if we consider the simple structure of construction pieces here, there are various ways to call these elements. I think each one of us would call it in a different way if we at least decide to use one language. But for example, this can be called a protrusion, a cylinder, a post, a stud, and this can be also called differently. And you can imagine if we start describing this in different terms, confusion can exist. So let me tell you that in the realm of construction pieces, these are called studs, and here they are called tubes. Now, if we consider two pieces and we want to describe them, then this is a piece with 8 studs, and this is a piece with 8 studs. So these are not sufficiently described to distinguish these two different data sets. So there should be another level of description which has to be agreed and agreed by a community, which labels these pieces in a proper category. So this is a brick with 8 studs. Oh, now I know it is this one. And this is a plate with 8 studs, and it's identified. And it also applies in this realm of construction pieces. All type of piece is categorized. The same should apply to our data. A controlled language is needed to properly document data that are obtained in different sources, in different laboratories, different countries, in order to enable interoperability. So I1 specifies the requirements on the language that we should use to describe the data. So simply, they should be formal, meaning that the language we use should follow certain rules and certain standards. They should be accessible. It means anyone can read them, learn them, and apply them to their own data sets. They should be shared in terms that the terms and the units are familiar across different people, and they should be broadly applicable. So the language and the terminologies used should be adaptable to various domains and contexts. Well, I2 is basically specifies that the terms and the vocabulary that we use to define the language and describe our data should also be fair in terms of everything that we have discussed: findable, accessible, interoperable, and reusable. I3 requires that both the data and the metadata can be connected to other objects that are related to them. So this connection should be made using a qualified reference. And the FAIR principles define what a qualified reference is in two aspects. One is that it should link to another resource with the persistent identifier PID, and also the relationship between the two objects should be defined. A tangible example can be seen when you upload your data to Zenodo, which is a generic repository. When you upload new data, then you have a field where you can enter the DOI or the identifier of a related item. And then from a drop-down menu, you can select how is this item related to the data that you are uploading. So the last principle is reusability. So after locating, accessing, working with the data, the next step is to reuse it in a different context, in your own experiment and your own field, as symbolized in this figure here. So the same piece is used in two different contexts. Several challenges are associated with the data reusability, such as an absence of a clear reuse license. Because if you don't have a license, it doesn't mean that you can use it. It just would keep you confused and unable to reuse the data. The lack of the metadata that can help you decide whether this data is suitable for your plant context or not. And also the ability to identify the history of the data set is not possible, and this would prevent you from finding who to contact in case you have questions. The accessibility foundational principle and its four, the reusability foundational principle and its four guiding principles aim to resolve these issues. They mainly provide guidelines on using accurate and rich metadata to describe the data in a way that potential users can make sure that they can use it in their context, and also relates to the licensing of the data. So R1 refers to ensuring the accuracy and plurality of descriptions of data and metadata. The aim here is to enable any potential user to assess whether the data are suitable for their purpose. And plurality here means that when you write your metadata, you shouldn't assume any specific, or you shouldn't assume any restriction to a specific community or user. You should be very general and assume that different fields can use your data, then the metadata should fit into that requirement or to that context. And here a common confusion is that principle R1 is confused with F2, because F2 also mentions that metadata should be described with rich metadata, but they are different in terms of the aims of each. So F data aims to have rich metadata to locate the data, while R1 aims to have the metadata prepared with a plurality so that people can assess whether it can be suitable or used in a specific context or field. The remaining three guiding principles of the reusability are further detailed in R1, R1.1 and R1.2 and R1.3. Simply like R1.1 requires the description of your data, and the metadata should include a clear data usage license without ambiguity. So the licenses have been discussed in Siamak's presentation earlier. So they have to be discussed clearly with your data so that users or reusers can know what to do with the data. R1.2 requires that detailed provenance of the data is included in the descriptions or the metadata. And provenance means that questions such as where the data came from and how it has been processed and who has had access to it. So all these questions should be answered in the provenance description of the data. And basically R1.3 simply states that when you prepare this plural metadata, it has to be adhered to the accepted practice and normalities in your community. So this brings me to the conclusion and last slide. The key messages that I try to send out here is that research data are the key outcome of the scientific research process. Effective communication of research data between scientists and across different domains can be enabled by applying the FAIR data principles. FAIR stands for the objectives to be achieved in order to make data machine actionable. And the 15 guiding principles that we have discussed, they provide a more detailed and a more measurable guidance towards achieving them. And to implement the FAIR principles and how to implement it is decided by each community, by each researcher. Just focus on achieving the objectives and work on the solutions that makes it happen. With this, thank you very much. And I believe that we have some time for questions.